Okay. Let us discuss how to construct a push-down automata for different languages. Okay. So let's see how to construct PDA for the language. Okay. L equal to WC, W per R, where W belongs to A and P. Okay. So this W can start with A. Okay. Or otherwise, W can start with B also. If AB is W, what can be W per R? W per R is B, reversal of the same string. In this case, what is W per R? W per R is AB. Am I right? So, for this case, what is your string B? Your string W followed by there should be a separator and there should be the reversal of the same string. Isn't it? For this, we are going to construct a push-down automata. So you have to decide whether to perform push operation or pop-out operation. Okay, for which set of symbol it is push and for which set of symbols it is pop-out. So for the entire W, it must be push operation, and for the entire W per R, it should be pop-out operation. Then what happens when it identifies the separator? C acts as a separator here. Again, let me repeat, it's a separator. So this case, we need not perform any operation. So we'll write no operation. Okay. So what happens then? Whenever the set of symbols, okay, belonging to W comes, we have to perform push operation. Okay. When it checks C, there is no operation, but there should be a state change. Okay. Then after changing a state, that is after maybe consuming all the set of symbols from W, when it checks the reversal of the same string, then pop operation should be performed. This is how we have to construct a push-down automata. Let me start writing the transitions here. Okay, transition function. Okay, let us write for push operation first. Okay, so transition function of will start with Q naught, and in the beginning, a first symbol itself can be A. Okay, so the bottommost element or the stack contains the initial element, is it not? So how do you write? It is push operation. Okay, Q naught comma A is not. Then how do you write the next transition? Suppose if the first symbol is P, then in that case also what are we doing? We are performing the same kind of push operation. B is not. Then what is our next step? Okay, if A is there on the top of the stack and if your input symbol is also A, what are we doing? We need to perform push operation. Okay. Suppose if A is there on the top of the stack and B comes as an input symbol, then also it must be the same operation. Okay, it should be BA. Then what's the next step? We have to write the transition function for all the combinations. Okay, suppose if the top of the stack consists of B and A is the input symbol, then it should be Q naught comma AB. Okay, transition function of Q naught comma top of the stack consists of B and the input symbol is also B. In that case, what you are doing? We have to perform push operation Q naught comma BB. All right, is it clear to everyone? So you can assume a stack like this. Initially, it can have Q naught. What is our first input symbol? A. A is pushed into a stack. Suppose in this case, what you have to do? So, is it not is the initial symbol? B should be pushed into a stack. What's the next input symbol? B. When B comes on the top, A is there. This should also be pushed into a stack. Okay, this case, what are we doing? B is there on the top of the stack. Okay, then if the input symbol is A, it is pushed into a stack. All right. Suppose if you have one more symbol, that also should be pushed into a stack. Say whatever the symbols be, okay. These are all the set of transitions to perform this push operation. But the next case, what is the next input symbol? So we have to write the transition function for no operation. What is the meaning? So whenever the push-to automata checks the separator C, that is Q naught comma C comma A. On the top, it can be A. Okay. If it is A, we are not performing any operation, but there should be a state change. From Q naught, it goes to Q1 and A remains as such. Then suppose on the top of the stack, we have symbol B. Okay. See, B is there on the top and we are verifying the separator C. So how can you write the transition function? It should be Q1 comma B. Then that's all. So we are here. W is been processed. C is also been processed. Now next we have to process W per R. So for W per R, what we have to do? We have to perform pop out operation. Pop. So to perform pop, suppose in this case, let's see your string W is AB. Okay, so both initially we have pushed A into the stack, then B is also inserted into the stack. Then what can you expect in W per R? So if B is there, anyhow, only B will come, right? So how do you write? Transition function of q1 comma then on the top if a is there maybe your input symbol should also be a. Am I right? If input symbol is a, on the top of the stack you can expect only a. So this case we are performing pop out operation. What's the next step? Suppose if b is a input symbol, what can you expect on the top of the stack? Top of the stack should also have b in it. Okay, so this case also we are performing pop-out operation. Then finally, if there are no more elements to process, that is epsilon is our input symbol and we have only the initial stack symbol is not. In that case, it will go to the final state. So the final state representation you can write like this q2 comma epsilon or otherwise it can be q2 comma epsilon. Right. So that's all. These are all the related transition functions for constructing a push-to automata. Okay, for WCW per R. How do you give a diagram? Q naught is our initial state. Then we have Q1. Then Q2 is our final state. Okay. So in state Q naught, what are we doing? Just look at the transition functions. In state Q naught, for A comma is not write it. A comma is not as such. Then this right hand side operation you have to separate it by using the symbol parallel operator like this. A is not as such you have to write. Then B comma is it not? It is B is it not? Then what's the next one you have to write? A comma A, it is AA. Then let me write it here. B comma A, it is BA. A comma B, it is AB. Okay. B comma B, it is BB. These are all the transition function. Okay. For W, to process W. Then when we process the separator C, it goes from Q0 to Q1. Okay. So C is the input symbol. Okay. C comma A. Am I right? C comma A, it is A alone. Same manner, C comma B, it is B. You have to write like this. Then when it is W per R, you have to write A comma A. See this case, you should write as J comma A epsilon, B comma B, it is epsilon. Okay. Then after processing this, when there is no more symbol to process, it will enter into a final state. This is a transition function for WCW per R. Okay. So we have constructed a push-down automata for the language WCW per R. Okay. All right. Let me stop sharing.